Okay, and I need the class. Oops. New project. No. So how is it going? Who finished? What screen are you on? Do you have HDMI cable? No. Yeah, do you have a second one? No. Yeah. Can you make the fonts a little bit bigger? Okay. So the first task was to write a function which swaps two parameters. So it is you pass it two arguments which are int, and then it returns them in the reverse order, right? So we have it done here with the equality assignment operator, which swaps the two things. So in Go, we have ability to do deconstructing, right? So we can return multiple things, and that's what the function does. Is there any other way of doing that? Yeah? Yes. So what is the advantage of doing it with pointers?
Because it changes the reference, now if you print the accent instead of out of the function, it won't change the numbers.
That's right. Yeah. So show me how you would have to use this one. So have you tried it? Yeah. So you have to use it with the assignment, right? If I don't reassign it, it will not work, right? And if I make a mistake, if I say yx here, it will reassign the same values to the same things, right? So it will not swap them. So if we did with pointers, it would change it. So can you rewrite it? So we use pointers. So what would be different? Yeah, and we don't need to return anything. So how should that be done? Who knows? Yes, exactly. No, not with those. Ah, yeah, with those as well. Yes, correct. Good. Yeah, perfect. All right. So what's changed? Why we have those stars there?
Now we are exchanging pointers and not values. Now the references are actually the same.
That's right. So we're using the star to get the value of the pointer, right? So when we pass the parameters, so x and y are not integers anymore. They are pointers to integers. So to get the integers, we have to use the star, right? And then to call the function, you don't need the semicolons. So you can delete all the semicolons you have here. Yeah. From C# or from C, you need them. For Go, you don't. So here we have to call ampersand x. So what's that?
So now we are passing the address actually.
That's right. So what is okay? So that's good. So that's exactly how to implement the swap. So who doesn't understand the swap function? Everybody understands it. Great. So if I go back to my screen, let me just change the fonts. It's okay or it's too small? So I will not, yeah, we can keep it hello world. So if I have a variable x, so I have a variable x, which is, I have a variable I, which is an integer, and then I say I is 10, and then I have a variable x, and I want the variable x to point to the same location as I do this, right? Yeah, yeah, it is. Uh, So I have, let's say I have variable x, which is a pointer to int, and I do this, right? And then I can say I is, and then to get the value of I can say I, or if I want to get it from x, I would have to say star x, right? So what's x? If I print x, what I will get? The address, right? So what will happen if I say x equals 10? Can I do that? So Go doesn't allow me to do that, right? So that's right. In C, it would set the memory address, right? But I can do star, right? And that changes, overrides the value. All right. So we have our first function swap. So we have a function swap, which takes two integers and swaps them, right? We've used pointers to do that. Now we want to write a test that it actually does what it's supposed to do. So now the second small function that you need to run, right, is how to test the swap function. How would you do that? And go. Who knows? Who knows how to write a test that will test our swap function? So our swap function, I just re-implemented here for the sake of being here. So I have A and B being pointers, and this function doesn't do anything. So my test should fail. So how do you do testing in Go? Well, you need to have a file which tests this file, because a lot of testing in Go is done by conventions, and I have my function in main.go. I should have a file called test. So I should have another Go file which is called main_test.go. So all the tests will go into the main_test, and normal stuff will be in the normal file. So that's in your hierarchy of files, that's what you do. So I have another project here, which is on GitHub, which we use for the student discussion of how the APIs work. And I have my files like API_student, and I have API_student_test. And database_test, and all the tests are in the _test, and all the normal stuff is in the normal files. So how do you write tests? Well, you have to write a function which is a test case, and by the convention you start your test cases with capital test underscore, and then you put the function that you're testing. So we're doing unit testing, which means we'll be testing a function. So in our case, I will put that I'm testing a swap function, because that's what I want to test. I want to test this function, right? So I will have a function which is called test_swap, and the IDE complains, well, you have the wrong signature, right? Because you should have a signature specific for the test cases, and the signature is that you have to have a one parameter, which is usually called t, and it's a pointer to testing t. So now the signature should be fine. Now it doesn't complain about the signature anymore, and I write my test. So you write your tests by whatever logic you need to test. So in our case, we have to do some preparations. So I need two numbers. So I need two integers. For example, A, which is 10, and B, which is 20, right? And I need to swap them. So I need to swap A with B. And now I have to test if the function did what it's supposed to do. So I have to say if A is not 20, then I have a problem. Or if B is different to 10, I have a problem, right? So I will say T error, the swap did not work. And that's my test. So I have a very simple test. I am doing some preparations. I'm doing the actual logic, and then I'm testing whether the logic did what it's supposed to do, right? So if I do that, and if I save it, and if I'm in command line, so I will bring the command line tools first. So if I go to my Where is it? Let's see. Yes, I have my stuff here. So I have my two files. So if I do main test, I have it here. So if I say go test current folder, what Go will do, it will build the current project. It will pick all the files which have underscore test with them. It will pick all the functions which have test underscore something, and it will run them. And then if any of them cause error or some failure, it will say that the test failed. And if all of them pass, it will say okay. So you can have it more verbose, you can have more details of what actually happens. And it says, I'm running a test swap, and it failed. And it failed in line 12 with the message the swap did not work. And now line 12 is the test, which says, okay, the swap didn't work, okay? So now I will go back to the main, and I will, implement it. So the implementation is that I need A and B to equal B and A, right? If I save that and go back to my IDE, so I will clear that, and now I will say run the tests without V. It just says, okay, all your tests passed. And if I want to see which test actually ran, I can do this dash V, and then I have a more detailed view of which tests passed, how long they took, and I will have a listing here, right? If you're using IDE, you can do the same. So you can set up, I can go to my running configurations, and I can say edit configurations, and I can say add go test, test all, go test. I don't change anything here, apply, okay. And now if I change it to test all and run it, I will have a kind of a nice nice IDE showing me all tests passed. It took 2 milliseconds and have details in the window, right? It's kind of integrated. All right, so what we will do now, we will write another function. So write another function which what we will pass to this function is we will pass to this function a string, and the string can be so the spec for the function is so we passing a string, pass a string, and the string will have letters A, B, C, D, E, F, and A will be worth 10, this will be worth 11, this will be 12, 13, 14, and 15. If there is any other letter passed to the string, we will not handle it for now, and the letters combine together. So I can pass a string, which is, for example, AAA, and that means 10, 10, 10. Okay? And what I want to be an output, I want this to be an output. So if I pass A, B, C, I want the output to be what? 10, 11, 12. All right. So write a function which we will call hex for no real special reason, and it will take s, which is a string, and it will return a string. Okay? While you're writing this function, I will write a test for this function. Okay? So, yeah. This should go. here, and what I will do, I will write another test case. Test our hex. So how's it going with the implementing? Who has done it? Yes, I'm bringing the spec again. Yeah, it's from A to F, and from 10 to 15. And the string, you can assume the string is always low letters, low caps, and it's correct that it will only have letters from this subset, from those 6 letters. So we're not handling unusual situations. But it can be longer than 3, of course. It can be 1 or it can be, 10. So you need some form of a loop to do that. Next, yeah. Well, yeah, it's a fairly good composting. Yeah, like that. And then trying to do it programmatically with the request and data structure with the of the response. Yeah, to extract it. Yeah, I hope so. Yeah. All right. So how does it go? Done? You've done it? You have HDMI output? Yeah. Great. Sorry? Only the factory. All right. So we have the implementation coming. All right. Can you make it a little bit bigger font? You go to probably file properties, I guess. Ah, perfect. That's so cool. Yeah. Great. So, what are we doing here? How does it work?
It receives the string.
Yeah.
It takes the string into the folder.
Yes.
And it just adds the string depending on the value.
Yeah. Great. So that's a very nice and tidy implementation using a case statement and a range loop over all the characters of the string, right? Any comments on this? You were thinking of similar solution? Or a giant if statement? If you were thinking of a giant if statement, I would kind of run upon it. The case is much more readable and much more concise than if the character is A, do this, if it's B, do this, right? So for something that is like more than 2 choices, if is usually not good. Case is better. All right. That's right. You could do that as well. Although that would be a little bit less readable. Okay. So if you were really after performance, or if you were doing it in C, you could do as you say. You could sort of because those string characters A, B, C, D, E, F, they are actually bytes. So you could calculate the offset, and you know, fingers crossed that they are consecutive in the ASCII table, which they are. But then it will be inflexible, because if I were to change the specification, and if I were to say actually we have to go by 2, right? If I change my mind and now I go like this, right? Ah, yeah, they can see. So if I changed 10 to 12 and 11 to 13 and so on, suddenly that method wouldn't work, right? So this is more flexible, it's readable, and it works well. It has one small problem. If you submit this code for the code review to some of the automated tools, they will complain that your complexity is very high, because each case statement counts as a kind of a complexity add-on. Okay, so each if statement, each case statement, and each kind of situation where your code forks into choice, it adds complexity, right? So I can kind of I will try to code complexity metric. Oh yeah, sorry. So if you check complexity metrics or cyclomatic complexity, you will notice that it kind of counts the cyclomatic complexity of a section of the code. Well, I made it too big now. So the cyclomatic complexity of a section of the source code is the number of linearly independent paths within that code. So every change, every kind of choice, like in this case we have 6 choices of 6 case statements, adds to this complexity metric, right? So if I look, if we look back at the code, which number are you? 12. Yep, but you remember it had 6 case statements with 6 choices, okay? And for each choice, it was doing something. It was adding this thing, right? So how could you rewrite it that you don't have choices? What could you do to re-implement it in such a way that you don't use if statements, or at least not more than one, and you don't use case statements? How could you do that? So I will start skeleton of my implementation. So we have this S. We iterating over the indexes and the character. Yeah, you don't see anything. Yes, I'm getting better. And we are ranging over S, right? So we have to do something, and we have our result. So we have our result being an empty string to start with. And now we have to build our result. So the result will be plus something that we need. And the puzzle is not to use any if statements. So what can we do to do this logic without using switch, case, or if statements? Yeah? A map, exactly, brilliant. So let's do a map. So let's say we have our magic mapping between our, you know, this looks like a map straight from the specification. So A maps to 10, B maps to 12, right? So I will say, okay, we have a map which maps string into a string, and it has a structure such that A maps to 10, and B maps to 11, and so on. Whoops. So I need 6 of those. So C, D, E, F, and this one maps to 15, 14, 13, 12, 11. And now I will say the result is my mapping of the C, because that will give me the yeah, that would work, but we don't really map strings, we map characters. So small mistake. And because we map characters, we will not map strings, we map, whoops, byte. So yeah, why it complains. Okay, has to be in 32. Now it's happy. All right, so we mapped our letters of the string into the and we'll return the final result. So now the code complexity is very low. We have no if statement, no cases. We have very concise implementation. So I have just those 3 lines of code to do the thing, which was similar, but the logic of adding stuff was more spread over the 6 lines of the case statement, and I have my specification in one place. I can load it somewhere else, or I can store it separately, right? It's not kind of encoded in my logic. It's encoded separately. I can isolate it into a text file or whatever I want, right? It's not part of my actual core logic. So this implementation is slightly nicer. The other one is fine, and with 6 case statements, it's not a big deal, but this one is slightly better, right? So using maps sometimes helps, and you should use maps. And we use maps all over the place when we're dealing with JSON or when we're dealing with things, right? All right, so let's test it. So I wrote a simple test. I wrote a simple test. Whoops, here. And my test says, okay, my input is A. If the output is 10, I'm done. It's all good, right? So I run it, and it checks the current code, and hopefully it will pass. Yes, it passed. What's wrong with this test? Yeah, so to start with, if I ignore all my logic and just return 10, my test will still pass, right? And my function doesn't really work. So the test is too trivial. Like, I need a little bit more testing to actually make sure that the logic really works, right? So I have to write a little bit more test cases. Okay, so that's one thing which is broken with the test. What else is broken? That's a kind of a small thing. Yeah, but it kind of relates to the first one, right? The second small broken thing is that I am testing here if the execution of this function returned me what I expect, right? And then if it didn't, I'm reporting by saying I was expecting 10, and then I call that logic again, right? I'm calling it second time in the test. So I'm calling it twice, once to test it and once to report it, right? As you know, functions can have side effects, and calling a function twice may have a different effect than calling it once, right? In this case, it shouldn't matter, but it's kind of a bad practice to call the logic of what you're testing outside of the core logic of your test, right? So what should happen is I should have got output and then call hex on input once, and never call hex again. I should just compare if it is if it's correct and report if it isn't, right? It's not a big deal for this case, but it's kind of a bad practice to do that, because you will have cases like, for example, a counter. If you call a counter that increments something and you called it twice, obviously it's going to increment it twice, right? So you should not do that. You should only do it once. So now the test is better, but it's still a bit crappy. So what should we do to make the test kind of very, very robust? Yeah?
Sorry, but shouldn't to make it more readable, shouldn't the output argument just remain expected and the button output remain like actual?
Perfect.
Make
Yeah.
it more readable?
Yes, we should do that. Yeah. So we should say expected and then actual. Yeah. Perfect. So that would be a good refactoring. But let's refactor it even further. Let's refactor it into something that's test cases. So my test cases will be a map between string yeah yep, and string. To make it more nice, I could have to follow on your comment, to make it even more readable, I could make a case where I have a struct which has input, expected output, right? And kind of name it nicely. But what I'm mapping is I'm mapping the input to expected output here, right? So if I have A, my expected output is what? 10. If I have AA, my expected output is 10, 10. If I have ABC, my expected output is 10, 11, 12, and so on. And I can iterate A, B, B, C, C, and make more and more complex test cases, including all the letters, and test everything nicely, right? And then my testing logic would be, I would say, for input expected range test cases, and do if so I'm calling hex on input is different than expected, then call t error failure, expected, and then you say expected actual. And now we have the same problem as before. So we introduce actual, which is x input. Alright, so we have if actual is different than expected, complain actual. Good, and we don't need this bit here. Okay. Okay, let's run. It's a little bit tedious to generate all those combinations here, right? So I could write a small routine which generates me permutations of strings up to say 12 characters with 2 of each of the letters, right? So starting from just A, kind of growing the string, I can kind of generate it in a nested loop, generate the test cases and test it, right? Instead of like writing it here. But if I were to generate it programmatically, I need a reliable swap function or hex function that converts me correctly the characters, right? Otherwise, I have to manually do that. But you got the idea, right? So you got the idea of how to use maps. You got the idea how to iterate over maps. You got the idea how to use pointers and how to write tests. Why do we write tests? What's the benefit of writing tests? Yeah.
Main benefit is when you are detecting some kind of error in the code. You can write a test that proves where is the error, then you can actually write so you can show that nothing else is broken while you fix the error.
Exactly. So when you're starting on a project, you don't have any code yet, then you write code. And then you manually test it that it works. So you write 1 function, 2 functions, 3 functions, and you've tested it manually that it works, and that's fine. And then you need to change something. You need to add new functionality, or you need to make it work for some case that you haven't worked before. And then you introduce a change, which may break what you already have, right? So we write tests to make sure that if you introduce new things, the old things still work. And also, as you pointed out, if you have a problem, then you write tests to demonstrate that you have a problem, and then you modify your code to satisfy the new test, and then the test stays with your code base. So in time, your tests grow and your code grows, and you have the guarantee that any new commits or any new changes to your code don't break old things. And that's why we write code, and that's why we like the code coverage to be quite high. So there is an additional icon here, and there is also additional flag that I can run with my tests. So if I say help, yeah, I don't think that works, but you can kind of you can check it out. There is a flag which calculates how many lines of your code the test touches while the test runs, okay? And this number here for me is 100 because I have really trivial, I have a very trivial, case. I have to be honest, I have a code which has two methods, two functions, hex and swap, and they are kind of like one-liners. So if I call swap, I have to execute this line, and then if I call hex, I have to execute the whole thing to the end. I mean, I don't even have if statement, right? So every time I call this function, I execute everything, right? And then I do have two tests which test those two functions, which means by definition I have to have 100%. But if you were to have more complex scenario where you have more code, sometimes you have if statements and so on, the test coverage calculates how many lines of code you're touching while the test is running, and then gives you a number. And we like this number to be high because that means you don't have, here. So I have, 100% for this case, but let's say you have 50%, which means 50% of your source code hasn't been tested. Like your test didn't touch 50% of your code. So if your program runs, you have a fair chance of something which runs which hasn't been tested, right? And it may dysfunction or it may misbehave. If I have 100% coverage, does it mean my code is bug-free? I don't have bugs anymore if I reach 100% here? No, of course not. You may still have bugs. You just don't have tests for those bugs yet, right? So the existence of bugs is, with tests we can only demonstrate that there are bugs, but we cannot prove that there are no bugs, okay? Can you have bugs in your tests? Yes, and it's very painful when that happens, right? So we try to avoid it. And there are two strategies to avoid bugs in tests. One strategy is something that we've been using here. Write short tests. Write very trivial short tests which are really hard to get wrong, okay? Don't make complex tests. If you have a complex test, try to split it in multiple tests which are very small and trivial, okay? This kind of helps to have bugs, to not have bugs in your tests. The other one is, I have a case a couple of years ago where we had quite a big code base, and we had a huge number of tests. And when you write your code and then you write the test, you kind of subconsciously write the test to pass, right? Because you've tested manually your code, and it works. So you write tests to pass, right? So you don't write tests that fail. So as soon as you roll the test and it passes, you say, okay, I'm done. I mean, that's all I needed to hear from the test, right? So you have a bias. You have a bias to write tests which pass. And then it may turn out that your tests pass for a wrong reason, and it actually is a wrong test. So I had a huge code base. We had like maybe 150 tests. All of them were passing, and then we found a bug. So as you suggested, I added a new test, 151 test, and I changed the code to make this test pass. And this test started passing, but it broke 30 other tests that I had in my test case. And I was like, whoa, that's weird. We go back and we checked all those 30 tests, and they were wrong. They were making wrong assumptions. That they were just passing for the wrong reason, and they should really fail. So we had to fix them, right? We had to fix the tests, not the code. So you have to try to do that. Try to write your tests early and try to write them small. Any questions? All right, so let's have a 10 minutes break. And then we will start half past with some REST API calls.
They should know either the RFC should not be. So if they have questions about semantics, point to RFC 7281, 31.
Okay.
Because I think they should learn reading those.
Yeah.
So
Sounds good.
they should have everything.
All right. So how many of you watched the video with the basic client server? Great. Those of you who didn't watch the video might need to do some catch up now. So what we're gonna do is, for the remainder of the session, we will do a small exercise. And Christopher find out kind of a nice word population API, which is a RESTful API exposed to the public by,
I'm not sure what data they use.
yeah. We don't know who actually does that. It's kind of, we're quite agnostic.
Exactly, we just care about that.
So it doesn't really matter. What matters is you can interrogate the public API and obtain some responses with JSON. And that's all we need, right? We need to play a little bit with JSON and we need to play a little bit with HTTP requests. So how about finding out what is the life expectancy of you living in Norway or you living in another country based on your date of birth and the country that you specify and whether you're male or female. So under the get specification for, let me make it a little bit bigger. You provide to this API, you provide a request, which is a get request, and the API endpoint is life-expectancy /total /sex, which is female or male, /country, which is a country in English, /date of birth, which is kind of year, month, day. And then if you execute it, you will get kind of a response. You will get the response body, which is a very, very, very nicely formatted JSON, and the response code, and the header. And what we can learn from the header, for example, is that they nicely use the application JSON content type. You get the size, you get the OK for the response, and you also get whether the response came from the cache or whether it has to be refetched. So it says miss from the cloud front, so it was not cached, it had to be fetched, and so on and so forth. So you can try it out with the kind of the interactive help here. The URL is api.population.io, and you have two tasks. One task is to just play with it right now with the browser. The second task is you used Postman. How many of you used Postman before? So try it again. Those of you who never played with Postman, that's a great playground to try out. Yep, something killed our monitors, yes. And then if you already got the Postman going and your request sends you the JSON back, issue the request from Go, get the body of the response from Go, and then parse this JSON into a simple JSON struct, which will have 4 fields, and then extract the total life expectancy out of the response, right? So make a very small Go program, which will probably be around 6 lines of code, where you issue the request to this URL, get the response back, get the body out of the response, decode it using the JSON struct that you declare, and read the total expectancy of the response from Go. Okay? So while you're doing that, we will also do that, and then at the end of the session we will sort of show you, or you will show us. Hopefully you will show us instead, but just in case, we also will do it because it's fun. Of course it's fun. All right, so Christopher, get cracking.
I just upgraded my Golang. That wasn't a good idea.
No.
Now I get this error. I've never seen it before. That's an interesting one. Name is not compatible with the version of Windows you're running. Check your computer